In 2017, Oumuamua became the first confirmed interstellar visitor to our solar system, sparking debates about its true nature. Now, with the recent discovery of 3I/Atlas in 2025, scientists are comparing these mysterious objects and finding that Oumuamua's bizarre properties look increasingly artificial. While most interstellar objects behave predictably, Oumuamua's strange acceleration, unusual shape and reflective surface continue to defy explanation. The more we learn about typical interstellar objects, the more Oumuamua stands out as something potentially extraordinary and possibly not natural at all. The discovery of 3I/Atlas. The discovery of 3I/Atlas in January 2025 by the Asteroid Terrestrial Impact Last Alert System marked humanity's third confirmed interstellar visitor. Unlike its predecessors, 3I/Atlas immediately displayed characteristics that astronomers expected from natural interstellar objects. Dr. Robert Warwick, who also discovered Oumuamua, led the initial observations that confirmed the object's hyperbolic trajectory and interstellar origin. 3I/Atlas measures approximately 200 meters in diameter and exhibits a normal comet-like behavior, with visible outgassing as it approaches the Sun. The object's spectroscopic signature matches typical solar system comets, containing water ice, carbon monoxide, and dust particles. Most importantly, 3I/Atlas follows predictable orbital mechanics without any unexplained acceleration. Its discovery comes at a crucial time when scientists are still debating the nature of Oumuamua, providing a control group for comparison. The stark differences between these interstellar visitors have only deepened the mystery surrounding Oumuamua's true identity and origin, making the earlier object appear increasingly anomalous in comparison. The Oumuamua discovery. On October 19, 2017, the Pan-STARRS-1 telescope in Hawaii detected a fast-moving object that would revolutionize our understanding of interstellar visitors. Initially designated A2017U1, the object's trajectory calculations revealed it was traveling too fast to be gravitationally bound to our solar system. Dr. Alan Fitzsimmons from Queen's University Belfast confirmed the object's interstellar origin within days of discovery. Scientists quickly realized they were observing humanity's first confirmed visitor from another star system, prompting an immediate naming ceremony. The object received the Hawaiian name Oumuamua, meaning messenger from afar arriving first, reflecting its historic significance. However, classification proved challenging. Oumuamua showed no visible coma or tail typically associated with comets, leading to its initial designation as an asteroid. Yet, its trajectory and composition didn't match typical asteroids either. Dr. Marco Michelli from the European Space Agency noted that Oumuamua represented an entirely new category of celestial object, requiring unprecedented international cooperation to study before it disappeared forever into deep space. Oumuamua's strange properties. Oumuamua's physical characteristics immediately set it apart from any known solar system object. Light curve analysis conducted by Dr. Karen Meach from the University of Hawaii revealed dramatic brightness variations of a 10-to-1 ratio, suggesting an extremely elongated shape unlike any asteroid or comet previously observed. The object appeared to be 400 meters long and only 40 meters wide, giving it a cigar-like appearance that tumbled end over end every 7.3 hours. Dr. Wes Fraser from Queen's University Belfast noted that such extreme elongation would be impossible for a natural object to maintain over interstellar distances without being torn apart by gravitational forces. Oumuamua's surface composition also proved puzzling. Spectroscopic observations showed a reddish coloration consistent with organic compounds, yet the object reflected sunlight far more efficiently than expected. The combination of unusual shape, high reflectivity, and lack of detectable water ice or other volatile compounds created a profile that matched no known category of cosmic debris, leading to intense speculation about its true nature and possible artificial origin. The acceleration mystery. The most perplexing aspect of Oumuamua really emerged when Dr. Marco Michelli analyzed precise tracking data from, multiple observatories. Rather than following a predictable gravitational trajectory, Oumuamua actually exhibited unexplained acceleration away from the Sun beginning in June 2017. This non-gravitational acceleration measured approximately 2.5 times 10 to the -4th meters per second squared. It's small but statistically significant and, consistent across multiple observations. Typically, such acceleration results from outgassing as comets approach the sun, creating a sort of rocket effect that pushes the object forward. However, Spitzer Space Telescope observations led by Dr. Davide Farnokia from NASA JPL found no evidence of dust particles, water vapor, or any other materials being ejected from Oumuamua's surface. The object appeared completely inert, showing no coma, tail, or detectable outgassing that could explain its acceleration. This combination of measurable thrust without a visible propulsion mechanism created an unprecedented puzzle in solar system dynamics, forcing scientists to consider explanations that challenge conventional understanding of how celestial objects behave in space, including, even the possibility of artificial technology. Scientific investigations. So, following Oumuamua's departure, scientists launched these intensive investigations to understand its, anomalous properties. Dr. Alan Jackson from Arizona State University led studies using Hubble Space Telescope data to refine measurements of the object's acceleration and rotation. The Spitzer Space Telescope observations, coordinated by Dr. Davide Farnokia, proved crucial in ruling out traditional comet-like outgassing as the source of Oumuamua's acceleration. These infrared observations detected no thermal emission from dust particles that would accompany normal cometary activity. Radio telescope arrays led by Breakthrough Listen conducted extensive searches for artificial signals but, honestly, found no evidence of technological emissions. Dr. Abraham Loeb from Harvard University argued that the lack of detectable outgassing, combined with the object's high reflectivity, suggested Oumuamua might have an artificial origin. The reflective surface discovery became particularly significant when scientists calculated that Oumuamua reflected 10 times more light than typical asteroids, indicating either an unusual composition or possibly an artificially manufactured surface designed for maximum light reflection, kinda like a solar sail technology. The alien hypothesis. Dr. Abraham Loeb, chair of Harvard's astronomy department, proposed the most controversial explanation for Oumuamua's behavior. It could be an artificial light sail created by an extraterrestrial civilization. In his 2021 book Extraterrestrial, Loeb argued that Oumuamua's combination of extreme elongation, high reflectivity, and unexplained acceleration matched theoretical designs for interstellar probes powered by starlight. The light sail hypothesis explained how Oumuamua could accelerate without detectable outgassing. Radiation pressure from sunlight could push against a thin, highly reflective surface, creating the observed non-gravitational forces. Dr. Loeb calculated that a sail just millimeters thick, but hundreds of meters wide, could generate the measured acceleration while remaining stable during its tumbling motion. He noted that such technology is already being developed by human civilization, making it, plausible that advanced aliens might deploy similar reconnaissance probes throughout the galaxy. The hypothesis gained attention because it provided a unified explanation for all of Oumuamua's anomalous properties, though it required accepting the extraordinary possibility that we had detected our first piece of alien technology visiting our solar system. The Dark Comet Theory. So, the Dark Comet Theory was put forward by Dr. Daryl Seligman from the University of Chicago and Dr. Gregory Laughlin from Yale University as a natural alternative to explain Oumuamua's mysterious acceleration. Their dark comet theory suggests that the object could actually be made up mostly of solid hydrogen, which would sublimate or turn directly from solid to gas when heated by the sun. Now, unlike water ice or other volatile substances, hydrogen gas is, basically invisible to most telescopes, and that could explain why no outgassing was detected, even though the object was speeding up. Dr. Seligman worked out that hydrogen ice could stay stable during its long interstellar journey through the cold vacuum of space, so the object's structure could be preserved over millions of years. Then, as Oumuamua got closer to the sun, the surface would heat up, causing hydrogen to sublimate and create these invisible jets of gas. Jets that could actually cause the weird acceleration scientists observed. The theory also helped explain the object's unusual density and structural stability. Hydrogen ice is light enough to let Oumuamua keep its elongated shape without collapsing under its own gravity. The ongoing debate. So the debate is still going strong. Even though the dark comet theory has a lot of scientific appeal, Dr. Abraham Loeb remains pretty skeptical of purely natural explanations for Oumuamua's behavior. In interviews from 2023, Loeb argued that the hydrogen ice hypothesis faces some significant problems, like, for example, the extreme rarity of hydrogen-rich objects in our solar system, and the really precise timing needed for such an object to visit Earth. He also pointed out that hydrogen ice would just keep sublimating during interstellar travel, which makes it pretty unlikely that enough material could actually survive the million-year journey from the nearest star systems. On the other hand, Dr. Seligman countered these objections with updated models, showing that subsurface hydrogen could stay protected beneath a thin crust of heavier materials. But, the scientific community is still deeply divided on Oumuamua's true nature. Dr. Jane Green from NASA Ames noted that both explanations require accepting either extremely rare natural phenomena or, honestly, unprecedented artificial technology. This whole debate really highlights some fundamental questions about scientific methodology, like do extraordinary claims require extraordinary evidence, and how should scientists approach phenomena that just don't fit into existing paradigms? It's definitely challenging our understanding of what's possible in the universe. Project Lyra mission concept. So, recognizing that ground-based observations just can't resolve the mystery of Oumuamua, Dr. Andreas Hein from the University of Luxembourg proposed something pretty ambitious: Project Lyra. It's a mission designed to intercept and study the object before it disappears forever. The mission concept, which was developed with collaboration from ESA and NASA, would launch a high-speed probe that's actually capable of catching up to Oumuamua, even with its velocity of 26 kilometers per second relative to Earth. Dr. Adam Hibbard from the Initiative for Interstellar Studies calculated that such a mission would need some really advanced propulsion technology, including ion drives and gravity assists from multiple planets, to reach the necessary speed. The probe would be equipped with high-resolution cameras, spectrometers, and particle detectors, so it could definitively determine Oumuamua's composition and structure. There are launch windows for Project Lyra until 2029, and after that, the object will just be too distant for any foreseeable technology to reach. Dr. Hein emphasized that this is basically humanity's only opportunity to directly examine our first confirmed interstellar visitor, and maybe answer one of the most important questions in astronomy. Are we looking at natural phenomena, or could this actually be alien technology? The Future Hunt. Looking to the future, the Vera C. Rubin Observatory, which will begin operations in 2025, represents our best hope for discovering and studying future interstellar visitors. Dr. Lynn Jones from the University of Washington is leading efforts to optimize the observatory's legacy survey of space and time, specifically for detecting objects like Oumuamua, and with enough advance warning to allow for detailed study. Thanks to the observatory's unprecedented sensitivity and wide field of view, it should be able to detect dozens of interstellar objects every year, giving us a statistical sample to figure out whether Oumuamua is a rare anomaly or part of a larger population of unusual visitors. Dr. Robert Warwick predicts that within 5 years we'll have enough interstellar object discoveries to definitively classify Oumuamua as either natural or artificial. If most interstellar visitors behave like normal comets and asteroids, then Oumuamua's uniqueness will only strengthen arguments for its artificial nature. But if a lot of interstellar objects show unusual properties, it could point to previously unknown natural formation processes. Either way, the ongoing mystery has already transformed asteroid and comet research, pushing scientists to expand their understanding of what's possible in the universe and to get ready for unexpected discoveries. The discovery of 3I/Atlas has actually given us some crucial context, making Oumuamua seem even more anomalous. While 3I/Atlas behaves exactly the way scientists expect natural interstellar objects to behave, Oumuamua's combination of unexplained acceleration, extreme elongation and high reflectivity just keeps defying conventional explanations. Whether it turns out to be advanced alien technology or an entirely new class of natural phenomena, Oumuamua has, without a doubt, permanently changed our perspective on what could be traveling between the stars. So, which explanation do you find most convincing? Share your thoughts below. And hey, if you enjoyed this cosmic mystery, hit like, share with your fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. A bombshell just dropped on the astronomical community, but it wasn't from space. While the West's most powerful telescopes were blind, Chinese observatories released crystal-clear images of the interstellar comet 3I Atlas. This isn't just about a new comet, it's about a seismic shift in who controls our view of the cosmos. This sudden pivot in the observational balance is stirring more than scientific curiosity. It may signal a new era in how we monitor these alien visitors. Let's explore this together.
Strange composition.
What if a visitor from another star system was a complete chemical stranger? That's exactly what we're seeing with 3I Atlas. This object is unlike anything that originated in our solar system. Observations so far have revealed a bizarre chemical fingerprint. Its coma, the gassy envelope around its nucleus, is dominated by carbon dioxide emissions, with a CO2 to water ratio far higher than any comet we've ever seen. Data from the James Webb Space Telescope confirm this, showing a CO2-rich coma with only trace amounts of water. For comparison, a typical solar system comet might have a CO2 to water ratio of around 10%, but initial findings for 3I Atlas hint at something dramatically different. This composition tells a story. As explained by cometary scientists like Martin Cordner, such a high abundance of CO2 suggests the object formed in an incredibly cold region of its home star system, a place far colder than our own Kuiper belt where even carbon dioxide gas freezes solid. The presence of irradiated ices and complex organics further deepens the mystery, suggesting its surface was battered by high-energy cosmic rays for millions of years as it traveled through the interstellar void. This isn't just a slight variation, it challenges our fundamental models of planet formation, which are almost entirely based on the architecture of our own solar system.
Telescopes go dark.
But what happens when our best eyes on the sky suddenly close right as this once-in-a-lifetime visitor is putting on its best show? This isn't a hypothetical fear, it's the reality that just unfolded. Major observatories like the Hubble Space Telescope, the JWST, and the European Southern Observatory's Very Large Telescope are the workhorses of modern astronomy. They provided the critical data that shaped our initial understanding of 3I Atlas. But these are incredibly complex machines. In mid-2024, Hubble had to switch to a single gyro mode, a necessary fix that nonetheless impacts its efficiency and scheduling flexibility. The VLT's four main telescopes periodically go offline for the recoding of their massive 8.2-meter primary mirrors, a delicate process that can take a telescope out of commission for weeks at a time. Even the JWST has faced challenges with its instruments. The transcript suggests several of these key Western telescopes went offline just as the comet's activity was evolving, creating a critical data gap. This isn't just bad luck. It exposes a systemic vulnerability in a highly centralized system, a single point of failure that can blind us at the worst possible moment.
China steps in.
Nature abhors a vacuum, and so does 21st century science. Into this observational gap, a new power has stepped in. China. Over the past 2 decades, China has invested massively in its astronomical capabilities, a strategic push outlined in its long-term science and technology development plans. The images of 3I Atlas didn't come from old equipment. They came from facilities like the Purple Mountain Observatory and the Xinglong Observatory, equipped with modern wide-field survey telescopes. These systems are capturing both the comet's detailed structure and the background star fields with stunning clarity. This capability is set to explode with the launch of the Zhangtian Space Telescope, a 2-meter observatory with a field of view 300 times larger than Hubble's, capable of surveying 40% of the entire sky over its 10-year mission. At a time when Western facilities are dark, observers in China are providing fresh frames of the coma and tail structures. This isn't just about filling a data gap, it's a strategic move that gives them a window to exercise scientific leadership. They have seized a historic opportunity, demonstrating that their long-term investment in astronomical infrastructure is now paying off on the world stage.
Data controls narrative.
Here's what really matters. In science, the person with the data writes the first draft of history. By capturing and publishing the first high-quality images of 3I Atlas during this critical window, Chinese teams will inevitably shape the scientific narrative. These initial observations become the reference points for all subsequent research. Think back to 1995, when Michel Mayor and Didier Queloz announced the discovery of 51 Pegasi b. Their data, showing a massive planet orbiting its star in just over 4 days, created the hot Jupiter category and dominated exoplanet theories for years. Similarly, the Chinese images might be the first to identify key features in 3i Atlas, setting the agenda for the entire global community. Their interpretations, published rapidly on preprint servers like Archive, will gain significant mindshare before the formal peer review process is even complete. In a scientific ecosystem where reputation and early access are paramount, this gives Chinese teams a powerful boost, allowing them to take the lead on developing the first credible models of this alien object's behavior and origins.
Data sovereignty.
This brings up a bigger, more complex issue. Who owns the data from another star system? For decades, Western astronomy, particularly NASA, has championed open data through archives like the Planetary Data System. This democratic approach allows any researcher, anywhere, to download and analyze raw data, fostering independent verification. However, this is not the only model. The European Southern Observatory often has a one-year proprietary period, giving the original observing team exclusive access to their hard-won data. As China's infrastructure grows, it can choose its own path. Data becomes a tool of soft power. If institutions like the National Astronomical Observatories of China control access to their 3i Atlas data, it could create data silos, complicating the creation of a complete global picture of the comet. The decision to release the raw FITS files, the standard format for astronomical data, complete with vital metadata, becomes a strategic choice that impacts not just science, but scientific diplomacy and the very culture of international collaboration.
National prestige.
Let's be clear, observing the cosmos is about discovery, but it's also about power. Space science is deeply intertwined with national pride and global influence. China has long used its space program to showcase its technological prowess. The Chang'e 5 mission in 2020 returned 1,731 grams of lunar material to Earth, the first sample return in over 44 years, a massive prestige victory. Releasing key images of a rare interstellar wanderer like 3i Atlas, especially when others cannot, is an equivalent statement in deep space science. The media narrative practically writes itself. China steps up when others falter. This resonates far beyond academic circles, bolstering national prestige and justifying massive government budgets for science and technology, creating a self-reinforcing cycle of investment and achievement. It reframes the 21st century space race as a contest not just of exploration, but of knowledge generation, positioning China as a leader in a frontier domain previously dominated by the West.
Infrastructure fragility.
Ultimately, the 3i Atlas incident exposes a fundamental crack in the foundation of global astronomy. For decades, the field has been shaped by a heavy reliance on just a handful of powerful, Western-funded flagship observatories, many of which are, geographically concentrated in places like Hawaii and Chile. But honestly, this model is fragile. This event serves as a stark reminder that our global network for monitoring the sky is just not robust enough. It really highlights the urgent need for diversification and support for projects like the Vera C. Rubin Observatory in Chile. Once operational, its 8.4-meter mirror and 3,200-megapixel camera will conduct the legacy survey of space and time, scanning the entire visible sky every few nights. This kind of continuous watch is a direct answer to the problem of missing transient events. The incident also underscores the importance of geographically distributed networks like the Square Kilometer Array, ensuring that no single point of failure, be it technical, political, or weather-related, can blind humanity to a critical cosmic event.
Verification questions.
New data is thrilling, but it arrives with a critical question. Can we trust it completely? The scientific process is built on verification, and integrating the Chinese data on 3i Atlas isn't simple. Are the new images calibrated in a way that is fully compatible with previous data? To answer that, the global community needs the raw FITS files and all associated calibration frames, the darks, biases, and flat fields required to remove instrument signatures. Without these, it's impossible to perform accurate photometry, the measurement of the comet's brightness, to see how its activity is changing over time. Furthermore, high-precision astrometry, or the exact measurement of the comet's position against background stars referenced by the Gaia catalog, is crucial. This data is needed to refine 3i Atlas's hyperbolic orbit and search for tiny non-gravitational forces caused by outgassing. Full transparency, including sharing data reduction pipelines, is the only way for the results to be independently replicated and universally accepted by the scientific community.
What the images reveal.
So, what could these Chinese images of 3I Atlas actually show us? They are far more than just snapshots, they are dense with physical clues. Astronomers like David Jewett at UCLA, who co-discovered the Kuiper Belt, would meticulously analyze the coma for structure. A faint jet, perhaps only a few arcseconds long, could reveal the spin axis of the nucleus and point to a specific active region. By measuring its surface brightness, one could estimate the dust production rate in kilograms per second and compare it to well-studied comets like 67P Churyumov-Gerasimenko. The transcript suggests that some releases show brightness falling off more rapidly in certain sectors, hinting at asymmetric outgassing. Most excitingly, a rapid sequence of images might capture a fragmentation event. If the nucleus were to split, as comet C2019Y4 did, these observations might be the only record of it happening, providing invaluable data on the structural integrity and tensile strength of an object from another star system.
Global wake-up call.
Bottom line, this event is a shock to the system of global astronomy. It's a wake-up call on multiple fronts. First, it forces a reckoning with the fragility of our observational infrastructure. It will likely accelerate pushes for more distributed networks and formalize coordination through frameworks similar to the International Asteroid Warning Network. Major observatories will likely reevaluate how target of opportunity time is allocated to ensure that high-priority interstellar objects get immediate coordinated follow-up. Second, it recalibrates the geopolitical landscape of space science, forcing Western institutions to forge new alliances and advocate for more resilient, internationally managed observatories. Finally, it shines a light on the changing nature of discovery itself. It's becoming less about a lone genius at an eyepiece and more about managing vast, complex, and sometimes fragile global systems of technology, data, and collaboration. The 3I Atlas event is a powerful case study in this new scientific reality.
What do you think this shift means for the future of astronomy? Is this increased competition a good thing for science, or does it risk fragmenting our global community? Let us know your thoughts in the comments below. We want to hear from you. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the cosmos. Thank you for watching Future Facts.
Voyager 1, humanity's pioneering explorer, has defied all expectations since its 1977 launch. Now, more than 4 decades into its journey beyond the heliosphere, it continues revealing hidden cosmic phenomena. Recent encounters in deep space have confirmed fears long held by scientists about the unknown dangers and mysteries lurking in interstellar space, fundamentally redefining our understanding of the universe and our place within it. The birth of a star sailor. Voyager 1 emerged from an era of unprecedented ambition and innovation, conceived during the 1970s as part of NASA's ambitious Voyager program designed to explore the outer solar system. Built by the Jet Propulsion Laboratory with project scientist Ed Stone overseeing the mission direction, Voyager 1 was equipped with an advanced suite of scientific instruments specifically designed to survive the harsh environment of deep space. Launched on September 5, 1977, it embarked on what would become humanity's most audacious journey into the cosmic unknown, destined to become the first human-made object to reach true interstellar space. The spacecraft carries humanity's hopes and dreams across the galaxy, immortalized in the included golden record containing sounds and images representing Earth's incredible diversity. This remarkable machine, weighing just 722 kilograms, would eventually travel farther from home than any other human creation, becoming our species' first ambassador to the stars and opening entirely new frontiers in space exploration that continue inspiring generations of scientists and dreamers worldwide. The Grand Tour. The Voyager mission represented an unprecedented grand tour of the outer planets, taking advantage of a rare planetary alignment that occurs only once every 175 years. Voyager 1's carefully planned trajectory included spectacular flybys of Jupiter in 1979 and Saturn in 1980, delivering breathtaking images and groundbreaking scientific data that completely transformed our understanding of planetary science. The spacecraft's discoveries included detailed observations of Jupiter's Great Red Spot, revealing its complex atmospheric dynamics, and unprecedented views of Saturn's intricate ring system, that showed structures far more complex than anyone had imagined. Each planetary encounter expanded our knowledge of the solar system's architecture while using gravitational assist to propel the spacecraft toward its ultimate destination in interstellar space. Project scientist Edward Stone marveled at how the mission consistently surpassed all initial goals and expectations, providing discoveries that revolutionized multiple fields of astronomy. The Grand Tour established Voyager as one of the most successful space missions in human history, setting the stage for even more remarkable discoveries that would come decades later as it ventured into the unknown realm beyond our solar system. The Golden Record. Voyager 1 famously carries the Golden Record, an extraordinary phonograph disc containing sounds and images carefully selected to represent Earth's incredible diversity and humanity's greatest achievements. Conceived and overseen by a team led by renowned astronomer Carl Sagan, this remarkable time capsule includes greetings in 55 languages, music from various cultures spanning classical compositions to folk songs, and natural sounds from Earth's environment including whale songs, thunderstorms, and human heartbeats. The record serves as both humanity's ultimate time capsule and our most ambitious attempt at communication with potential extraterrestrial intelligence that might someday encounter the spacecraft drifting through interstellar space. The Golden Record's ingenious design included detailed instructions for decoding its contents, with diagrams showing how to construct a record player and locate Earth within the galaxy using pulsar map coordinates. Decades later, this golden disc has become an enduring symbol of human unity, curiosity, and our deep desire for connection across the vast cosmos, immortalizing our quest to reach beyond our planetary boundaries and establish meaningful contact with whatever intelligent life might exist among the stars. Years in the void. For more than 4 decades, Voyager 1 has journeyed through the vast darkness of space, continuously transmitting invaluable scientific data as it passed beyond the asteroid belt and entered the outer reaches of our solar system. Despite traveling more than 150 astronomical units from the Sun, a distance so immense that radio signals now take over 22 hours to reach Earth, its sophisticated instruments continue functioning remarkably well, providing unique insights into space weather patterns, cosmic ray behavior, and the complex dynamics of solar-wind interactions. Mission operations at NASA's Jet Propulsion Laboratory have faced unprecedented challenges including steadily weakening power levels, extreme communication delays, and the need to manage aging systems designed in the 1970s using modern computer technology. Engineers have performed miraculous feats of remote troubleshooting, developing innovative techniques to maintain spacecraft health across interstellar distances while conserving precious power resources. Voyager 1's extraordinary longevity represents a testament to both robust engineering design and humanity's persistent determination to explore frontiers far beyond our known boundaries, proving that human ingenuity can overcome seemingly impossible technical challenges. Crossing the boundary. In August 2012, Voyager 1 achieved a historic milestone by crossing the heliopause, the mysterious boundary where the sun's influence dramatically diminishes and true interstellar space begins. This unprecedented achievement represented humanity's first tentative step into the vast galactic environment beyond our solar system's protective bubble. Scientific instruments on board detected dramatic changes in plasma density, magnetic field strength, and cosmic ray intensity, providing definitive evidence that the spacecraft had entered an entirely new cosmic environment never before directly explored by human technology. The spacecraft's signals confirmed that solar wind particles had given way to the interstellar medium, a historic validation of decades-old theoretical models about the heliosphere's structure and behavior. Mission scientist Ed Stone heralded this discovery as a triumph of human exploration, marking humanity's transition from inhabitants of a single solar system to active explorers of the broader galactic neighborhood. Subsequent measurements have continued refining our understanding of this complex boundary region, revealing unexpected turbulence and magnetic field configurations that challenge existing models. This crossing established Voyager 1 as humanity's first true interstellar spacecraft, opening entirely new chapters in space exploration and cosmic discovery. Signals from nowhere. Voyager's sophisticated instruments have detected enigmatic radio signals emanating from regions far beyond our solar system, creating one of the most perplexing mysteries in modern astrophysics. These mysterious signals from nowhere exhibit unusual patterns and characteristics that remain inconsistent with any known natural sources or previously understood cosmic phenomena. Leading the investigation into these anomalous transmissions, astrophysicist Donald Gurnett and his research team continue analyzing whether these signals originate from interstellar plasma oscillations, unknown cosmic ray interactions, or potentially even more exotic phenomena that challenge current understanding of physics. Some researchers hypothesize that these signals might result from interactions with mysterious magnetic structures, unknown particle fields, or previously undiscovered processes operating within the interstellar medium itself. The phenomenon has forced scientists to reconsider existing astrophysical models and may point toward entirely new physics operating in the vast spaces between stars. These continuing discoveries affirm that our galaxy remains profoundly mysterious, harboring phenomena that extend far beyond current scientific comprehension, and suggesting that interstellar space contains secrets that could revolutionize our understanding of cosmic processes and the fundamental nature of reality itself. The temperature mystery. Temperature measurements from Voyager 1 continue defying initial scientific expectations and creating new puzzles about the nature of interstellar space. Despite existing in the supposedly frigid environment beyond the heliosphere, instruments aboard the spacecraft have recorded unexpected temperature fluctuations and anomalously warm zones that challenge conventional models of interstellar medium behavior. Leading researcher Bill Kurth and his colleagues have analyzed extensive data suggesting complex thermal processes and unprecedented turbulence occurring in this mysterious boundary region between solar and galactic environments. These surprising findings significantly complicate existing models of interstellar medium properties, implying far more dynamic and complex interactions between particles, magnetic fields, and energy sources than previously theorized by astrophysicists. The temperature anomalies suggest active heating mechanisms that could involve magnetic field reconnection events, shockwave propagation, or entirely unknown physical processes operating on galactic scales. Understanding these thermal mysteries offers crucial insights about our Sun's broader galactic environment and potential hazards that future spacecraft might encounter when venturing beyond our solar system. The discoveries underscore how much remains unknown about the cosmic environment surrounding our solar system and the fundamental processes shaping interstellar space. Changing course. Voyager 1's trajectory has exhibited subtle but measurable course changes over time, creating new mysteries about forces operating in interstellar space. These deviations appear to result from complex gravitational influences and unexpected interactions with interstellar matter that weren't fully anticipated by mission planners. Analysts at NASA's Jet Propulsion Laboratory, including project scientist Suzanne Dodd, have carefully documented trajectory deviations that cannot be completely explained by existing models of solar gravitational effects alone. The observed course changes may arise from interstellar wind pressures, gravitational effects from unseen cosmic structures, or potentially even interactions with dark matter concentrations or gas clouds drifting through our local galactic neighborhood. Continuous tracking and sophisticated data analysis provide valuable insights that inform navigation strategies and propulsion requirements for future deep space missions venturing beyond the heliosphere. These findings highlight the remarkably dynamic nature of the galactic environment and demonstrate the critical need for adaptive mission designs capable of responding to unexpected conditions. The trajectory modifications reveal that interstellar space contains forces and influences that extend far beyond current scientific understanding, suggesting that future interstellar missions will face challenges that remain largely unknown and unpredictable. Ghost in the machine. The spacecraft's onboard systems occasionally exhibit unexplained glitches and anomalous behavior that has led some mission specialists to speculate about a metaphorical ghost in the machine affecting Voyager's operations. NASA engineers continuously address these technological anomalies through increasingly sophisticated remote troubleshooting techniques, working across impossible distances to maintain spacecraft functionality. Some hypothesized issues relate to cosmic radiation impacts, gradually affecting electronic components, while others may result from normal aging processes in hardware systems originally designed for much shorter operational lifespans. The mysterious nature of these intermittent glitches adds a distinctly human element to the otherwise mechanical journey of Voyager 1 through the cosmic void. Mission engineer Linda Spilker frequently remarks on the extraordinary challenges of operating technology that's now over 4 decades old, while maintaining functionality across interstellar distances that test the absolute limits of human engineering capabilities. These technical anomalies serve as constant reminders of the spacecraft's remarkable resilience and the incredible ingenuity of the engineering teams who continue supporting its mission. The glitches also highlight how little we understand about the long-term effects of interstellar environment exposure on sophisticated electronic systems, creating valuable lessons for future interstellar mission design. Patterns within patterns. Voyager 1's continuous stream of scientific data has revealed intricate nested patterns in cosmic rays, magnetic fields, and plasma waves that researchers have dubbed patterns within patterns, complex structures that hint at deeper organizational principles operating throughout interstellar space. Leading physicist Donald Gurnett uses these unprecedented observations to develop sophisticated computer models of the interstellar medium's complex structure, revealing organizational patterns that extend across vast scales throughout our local galactic neighborhood. These nested fluctuations and systematic variations hint at turbulent cascade processes and magnetic reconnection events that may be actively shaping the galaxy's environmental conditions over cosmic timescales. The continuous analysis and interpretation of such cosmic complexity underscores the virtually endless frontier that astrophysical research represents and humanity's enduring quest to understand our place within the broader universe. Each new data transmission from Voyager reveals additional layers of cosmic organization that challenge existing theoretical frameworks and demand new approaches to understanding galactic physics. The discoveries demonstrate that even the seemingly empty spaces between stars contain rich, dynamic structures that influence cosmic evolution processes. These patterns suggest that interstellar space operates according to fundamental physical principles that remain largely mysterious, despite decades of intensive scientific investigation and theoretical development. Voyager 1's impossible encounter with the mysteries of deep space has both confirmed our worst fears and revealed profound cosmic secrets that challenge everything we thought we knew. As humanity's first interstellar ambassador, it continues providing unprecedented insights into phenomena beyond our solar system. The spacecraft's remarkable journey highlights both human ingenuity and the vast mysteries awaiting discovery in the cosmos. Which of these revelations surprised you most? Share your thoughts below. If you found this cosmic journey fascinating, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more extraordinary discoveries from the final frontier.